Welcome to Lovelace Academy, third module of Plutus Experience. In this module, we're gonna start our first web app application using Purescript and UtxOs. Function composition. I guess that's probably the normally the most difficult one to understand, but I try to explain the best way that I can. Here's an example of this main function. As before, we have this log, and remember this evaluate one step each time. So log for this thing and log for another thing here. Okay, do not worry about this. I'm gonna explain this in the future, but like before, we have this show function, and we should be how do you gonna see that? Is just we have a way to transform that it receives some value and returns a string. Okay, and this some value we are returning here is the return from run car. So we have this car type, and we are somehow showing this. We are somehow converting this to a string, and we are passing this string to log, and log is then showing that in this screen. Okay. So let's evaluate this first. Okay. Let's see what's gonna have as output here. So main here is logging two things. So we have a first car here and a second car, which its values. Okay. What is inside of this car? Let's see. Car has the first value is a time, and you can see time is a number. So in both cases we have time with 2. Okay. The second value is distance. So we have same distance in both. Okay. Is distance is also a number. Everything here is a number. There's no difference. It's just an alias, like I said before. Type is just alias. Okay. Fuel also number. The third value and for both is 40. Okay. Third one is efficiency, also number, and the last one is velocity. And you can see fuel is efficiency actually is 0.5, and if velocity is 80. Okay. And the first log we are calling run car, and we are passing the same car here, and you can see it receives is the same structure, but it has different distance. Okay, different distance and different fuel, less fuel actually, you can see, and for the remaining values is the same. So basically we are computing how much distance the car traveled and how much fuel or gas it has used when we call this run car function. Okay, so this is a very simple problem. Given that we have this velocity in the car, 18 I don't know, kilometers per hour, but can also work the same way to miles per hours. Given this efficient of, I don't know, 50% how much I could travel with my car, and how much gas I could have in the end of this traveling. So we have this run car function, which takes a car, as you can see here, and returns a car. Okay, very simple. It's not so complicated. The first one showed us that with this velocity of 80 and this half efficiency and fuel tank of 200, we had traveled up to 106 something. I don't care about the metrics, actually. Um, but it could be like kilometers, for example. And we still have a tank with 40, gallons. Anything else, the metrics doesn't really matter. So the change values, like I said before, is just the distance and the fuel, and everything is just a read-only value. Okay, let's see what is inside this function. And imagine that we could implement that using, I don't know, let in variables to compute the values and then return a new value, for example. Could work the same way, but I'm trying to show you how to compose functions, so that's why we're using this. So we have two functions, set distance and set fuel. Okay, and if you take a look at the set distance, it's a function that receives a car and returns a car. So it receives this car object and extracts its value, all values inside of this R object. And remember, the first one is the time, the second is the distance, the third is the fuel, the next one is the efficiency, and the last one is velocity. And we are just building a new car with the same t, and we are adding distance here, and we are summed together with velocity times t. So it's basically the way that you can compute a travel distance using some average velocity, just velocity, I guess. Then we apply the same g and e and ev, so we're not changing anything. And remember that I said, how do you change values, mutate values in an immutable only world? So that's normally the way that you do that. You don't actually mutate things. You try to avoid mutating. You could, but you try to avoid mutate things, and you just replace them with new values, okay? That change accordingly the given parameters, okay? That's to keep code sane, that's to keep code purity, and keeps things scalable. So for things like that, it's really nice to have immutability by default. And there are also other ways of doing that, and even better ways, but it's beyond the content of this lecture. So let's move on. So the second function we have here is the set fuel function. You can see it also takes a car, same type. It takes a car, returns a new car, and we extract the value of the car object, and we compute, in this case now, the fuel, so the gas. We get G here and compute the new G, so we extract from the current G d times E times T. So that's the way that I computed the gas consumption, but it could be something different. I don't know if it's the correct, but it's the way that I did that. And the remaining values we just pass through. So we have this new car having this new value as before. And you can see that's a clear sign here. This is like a direction. There's a direction on this operator. So let's take a look at this operator. This operator comes from prelude. Okay, it's in prelude. And you can see here. Here, okay. It's from this module. Okay. It's also in prelude package. So the prelude here, just re-export that. And if you take a look at the signature, you can see, okay, this is a compose. Okay, compose function. And if you take a look at the compose function, we don't care about the class thing right now. It's beyond this lecture. I'm going to show you soon how to read those types. But for the function here, you can see that it's pretty simple. It receives something with 3 arguments, and you can see something here. So this is another way, like before we have used parentheses to define with arrows to define a function. Let me show you this clearly here. This guy here is the same thing as this thing here. So you can really understand what I mean. It's like a abbreviated form of that, you know? So this basically means the same thing. So here we have a function and we have another function, and the returning function have something different. What is different? So the first function is receiving E, C, so an argument E, an argument C, and return a D value. The second function is receiving an E argument, a B argument, which is not have seen before, and is returning a C value, okay? So you can see the C match this guy here, okay? It's returning a function from E. It takes E, it takes the B value, and returns the D value. If you take a look close at this, you're gonna see that we are piping them together. How are we doing that? We just pass, we build a new function, and this new function is gonna take a value, which in this case is car, right? It's gonna pass through this set function, so it's gonna be this car here. It's gonna return a new car, and this new car is gonna be passed as parameter of this next function. So set distance is receiving this modified car, then is returning a new car that is the same return from this run car function. So in my head, is that the way that I look at that? I pipe them together. Imagine real pipes. And you connect pipe together, and you put some input, and the input produce some outputs, and this output is piped in another pipe, and this transforms the value, and the output should be another value. It can also have direction. So pipe have this direction, so it comes from one function and goes to another function, and then for another function, and so on. So this is what is happening in run car. The car given here in this function is being passed through set distance, which is producing a new car, which is being piped in the set function, which produces a new car, then is returning this run car function. Okay, then we can have, if you have one direction, we could have another direction also. So for that, I have used this run car tick, which is just a variation. Is the same value as you can see, and it produces the same output. So in this run car tick function, we first set distance. Okay, same thing. We first set distance, then we set fuel. So it's just the reversed order of the piping. So it comes first to the this set distance function, then go through state, set fuel distance, but other way around, reverse it away. Yeah, that's finished the function composite. It's that simple. The reasoning is not so easy. I mean, it could get hard to understand, but I will leave some links so you can get more info on composition, and there are also nice articles and also videos. You could look for function composition, and in YouTube you're gonna see a lot of good explanations and visual explanations of how function composition works. The reasoning on function composition is not so easy, so I would recommend you the George's reference again. There's a deep explanation on FP, of functional programming principles that show how function composition works. And you could also look somewhere else, like YouTube. You're probably gonna see more explanations about how function composition works. But I believe that ends our lecture on Purescript for today.